this, and we move immediately to another potential technology block, which would be multi-access edge computing, or MEC. And without further ado, I pass the floor to Dario Sabella, who is the chair of ETSI MEC Industry Specification Group. But just first, allow me to insist that we're running a little bit late, so please keep your presentations as concise as possible. Thank you.
Thank you so much. Hello, everybody. Let me try to share my screen, and then we can go to my presentation. Can you see my screen? Just give me a confirmation that you can see my screen, and then I can start.
We can.
Okay, thank you so much. Thank you. So, hello, everybody. My name is Dario Sabella. I'm chairman of ETSI MEC. I am pleased to be here and quickly give you an overview of what we are doing in this standard group. The acronym stands for Multi-Access Edge Computing. And of course, I will just give you a high-level overview of what we are doing. Essentially, we are standardizing cloud computing at the edge of the network. I have no time to present you a nice video clip produced by ETSI on this perspective to show what's, let's say, the fundamental technology that we are pushing to the standardization here. But in the slides that will be shared, you can have a look to this nice video clip by yourself. So I wanted to present you the group. First of all, is a very diverse ecosystem of stakeholders, the growing membership of 121 members across operators, technology vendors, IT players, application developers, is creating a full set of standards, also leveraging virtualization of the network and in collaboration with many other standard organizations. As I said, the multi-access edge computing stands for, let's say, a standard which is not only based on wireless 5G networks, but also Wi-Fi and fixed access networks. And we are also collaborating in that perspective with other standard bodies like 3GPP, of course, and ETSI. And we are producing as well standards, but also white paper to complement what is done in the specifications. And I will show you also a set of activities which are targeting the engagement of application development community. Why? Because actually, this is the essence of MEC. MEC offers to application developers and content providers cloud computing capabilities and IT service environment at the edge of the network. So in a nutshell, who is our customer? This standard, if you allow me the term, is application developer and content provider. Of course, we want to engage infrastructure owners, but for the success of edge computing, standardization is equally important to approach application developers. We need to encourage an ecosystem of applications at the edge of the network. And that's why we are trying to address existential question for application developers, how to build applications on the edge. So, and for that, we are doing a set of things, and our basic approach of the standard is, of course, to produce an open standard, allowing multiple implementations and ensuring interoperability. Of course, as I said, we are based on a virtualization framework based on ETSI principles. We are aligning with 3GPP for MEC in 5G deployments, but of course, our standard is access agnostic. This is important to highlight, and also addressing the need of a wider ecosystem, so enabling multiple vertical segments like automotive and federations. The next speaker will talk more about the federation. I just wanted to mention we have established a collaboration with the 5G Automotive Association that recently joined the MEC membership on the automotive domain. So as I said, MEC is addressing the needs of many use cases. Is critical as an enabler technology for 5G, but also I will say also beyond 5G, and we are also exploring the ISG MEC possible topics for the evolution of MEC in more 5G mature systems, and why not also on 6G, of course. And but let me emphasize now what we are, let's say, putting into standards essentially as a key enabling technology for application developers is a set of APIs to address the needs of application development communities, and then we are defining a sort of APIs coming from industrial needs as exemplary implementation of functionalities that can be offered to application developer at the edge, exploiting RESTful based HTTP messages with a universally recognized language for application developers. And also it's important to highlight also other additional APIs can be standardized, but also added by third parties without the need to be standardized, as long as they are respecting the common principles and guidelines for the API design. And this is very important. For that, in fact, we are trying also to approach the developer community and studying an abstracted radio network information API to address the need of different vertical market segments like AR, VR, V2X, logistics, future factories, coordinated robots and drones, and so on and so forth. The goal is to provide an abstraction layer as a developer-friendly API that hides the complexity and requires only little technical skills and knowledge of the underlying radio network. This is a very important also for the edge computing standardization success and for the adoption of MEC technologies. And of course, we are establishing a collaboration with the other industrial organizations like 5G-AA, 5G-ACIA, and open source projects. And in this slide, I'm just showing you the huge list of activities starting from MEC phase 1, MEC phase 2, and now we are in MEC phase 3, started the past year in 2021 when I was starting as a chairman. This is a third phase of MEC standardization, and we are widening now the scope of ETSI MEC, considering also heterogeneous cloud, MEC security, cybersecurity, kind of new type of deployments, and so on and so forth. And then with this last slide, just to be very short, I wanted to give you just the flavor of the additional activities that we are carrying out, equally important to approach ecosystem of developers, like publication of open source APIs under open API representation, testing and performance. We are establishing an ecosystem wiki page with the relevant examples of implementations of MEC proof of concepts, also deployment trials, and an implementation of MEC sandbox that can be used by hackathons developers in the challenges and competitions. We are collaborating with open source projects, doing blog test events like interoperability events, and also publishing MEC Tech series as a tutorial for MEC technologies. And with that, I am concluding my presentation, and thank you for the attention.
Thank you, Dario. And the floor goes to Dr. Lee, who is member of ETSI, the same specification group, and also works for SK Telecom. Dr. Lee.
Hi, hello. Can you hear me?
Yes, we can.
I share my screen. I hope it can share. It can show, right? Can you see my screen? Okay, it is working. Hello. My name is Hyun-Soo Lee from SK Telecom. Following the Dario's presentation, I would like to share the standard work for MEC Federation and briefly introduce the current status of SKT's MEC business. Okay, actually MEC Federation started from the industry requirement such as GSMA. GSMA doing operator platform project, which is to expose operators' capability to the third party. So GSMA initially focusing on the edge computing, and also GSMA defined the federated concept as the most important feature. So accordingly, Edge MEC started a study item for the MEC Federation, and we already published last year. So there are several cases for the MEC Federation, but here I like to share two main use cases. The first one is the V2X service. The V2X service is considered as the most important service for the edge environment because the V2X services requires low latency and the real-time communication. However, in the reality, vehicle itself is continuously moving and requires a lot of communication with various other systems such as roadside infrastructure. So the interoperability between MEC system, between operators, between the manufacturers are mandatorily required, which are the feature for the MEC Federation. And second use case is AR game. The AR game generates a lot of data, so it is also the great example for the edge environment. However, as you can see the left figure, without MEC Federation, the edge service quality cannot be consistent between the users over the different MEC system, even though those users are doing the same game. However, we can support the MEC Federation. MEC Federation can secure the communication path between the two different systems, so it can improve the user experience. So the Edge completed the study item for MEC Federation last year. Now Edge doing the normative standardization work. So Edge has defined the use case and requirements and updated Edge MEC normative architecture. And now we are starting the new work item for the MEC Federation enablement API. And I expect that we can complete this new work item this year. As I said to the first slide, the MEC Federation refers to the GSMA OP requirement. So the current work of the Edge is totally aligned with the GSMA requirement and APIs. And in order to prevent the fragmentation of each standard bodies, Edge has a workshop with GSMA occasionally and also nominated two observers to help the smooth communication, smooth collaboration with GSMA. And I did not mention here, Edge also is constantly cooperating with 3GPP itself. Next, I would like to introduce the current status of the Sktp MEC business. Skt pursuing two strategies at the same time. The first one is to provide the public edge for nationwide edge service. And the second strategy is to provide on-site edge service to meet the specific industrial needs. So in addition, Skt is working with the various global partners such as Amazon or Microsoft. This figure, here is the figure that Skt doing the launch 2 years ago. The Skt raced towards the Korean Old Palace with the AR technology and successfully deployed this service over the MEC environment. This case is actually introduced in the many global media, including the MWC. It's very good example. And Skt has been actually cooperating with the global partners, including HP, Dell, VMware, and etc. over the past 2 years. And through this collaboration, Skt expects to contribute the global MEC business as well as Korea. There are 3 insights that SKT can obtain through these various POC. The first one is that because MEC business itself is really beginning stage, so it is required to provide the MEC-based services integrated to the MEC infrastructure at the same time. And the second is that in-house development aligned with the global standard should be required. And the final one is in order to lower the barrier for the MEC business, it is considered to provide a lightweight system. As for the MEC service integration, the SKT has considered the MEC characteristic itself and the market opportunity and the technology maturity. SKT selected two main target services. The first one is MEC Media and the Vision AI MEC. So SKT developing to provide integrated those services along with MEC infrastructure. And second is that the in-house development, as I said, to promote the SKT is preparing for the global business. So to promote the global MEC business, the SKT MEC system has to have a compatibility with ETSI MEC global standard. And also SKT is actively engaged in the standardization work, such as ETSI and the GSMA. And finally is the SKT aims to provide the MEC as a service in order that global partners quickly consider the MEC system without a big initial burden. Here is also I would like to show the MEC Federation POC of the SK Telecom. SKT is a main member of a bridge alliance where the Asia Pacific operators join here, and SKT successfully performed the POC for the application package onboarding POC over MEC Federation environment with Singtel. So based on this experience, SKT is seeking to new opportunities for the MEC Federation. So actually, this is a short video clip to show the overall status of SKT's MEC solution, and I hope we can have a time. That is all of my presentation. Thank you. Oh, sorry.
Okay, thank you very much, Dr. Lee. I think now we can pass to Dr. Park, who is the director of Ericsson-LG and also vice chair of TTA. I'm a bit mindful of the time, so if you can kindly keep your presentation concise, that would be much appreciated. Then we can recuperate some of the time overstretched so far. Thank you.
Okay, thank you. My name is Dong-Ji Park, and I will introduce the MEC status in Korea from the perspective of standard and EM 5G introduction. I'm a vice chair of TTA's PG related to the mobile system technology application to the various kind of industries. First of all, I want to introduce the MEC standard status that this figure shows a TTA technical report that describes the NFV environment and the MEC application technologies. It is based on the NFV and MEC standard. This technical report shows application methods and the technologies of MEC applicable to the various kind of industries. And the next is edge computing related TTA standard. First one is the TTA standard. It is based on a 3GPP 5G system enhancement for edge computing. So the 3GPP technology standard is applied for the TTA standard as a 3GPP edge computing application in the local industry. The other one is the 5G technology for industry with the edge computing technology. That shows that describes the 3GPP based edge computing technology and how the technology can be applied for the various kind of applications. For example, the use cases and methods and the markets and are described in this TTA technical report. Another one for the local activities of MEC is a MEC forum. MEC forum is organized from the industries such as mobile industry companies and application areas and academias and so on. And one of the MEC forums committee called as Technology and Standard Committee, they are devoted to the local standardization of the MEC application to the industry. So they have made some local standard MEC forum standard of MEC. And they said that this kind of local standard will be applied to the TTA standardization this year. From the perspective of the MEC technology application to the various kind of industries, I want to firstly introduce the current status of 5G. From the milestone of 2018, the spectrum auction was started, and April 2019, 5G NSA commercial launch with a smartphone was started. And at the end of that year, last January, last year, 93% of population coverage was covered with 169 kilo sites were deployed in 85 cities. So our technology was fastly shifted from the LTE to the 5G. So October last year, a time frame, more than 25% of the subscription was occupied by the 5G technologies. Based on this successful deployment of 5G in B2C areas, Korea government and the related people are interested in the extension of the 5G application to the various kind of industries. So Korea government announced that the Korean 5G plus strategy. It is based on 5 core services: realistic contents, smart factory, automated vehicle, smart city, digital healthcare as a 5G core services. Korea government support the 10 core industries to develop the technologies and services and use cases to support the 5 core services. So this 10 core industries are drone, AR, VR, edge computing, 5G V2X, and intelligent CCTV, wearable devices, and network equipment, and so on. As you can see, that the edge computing is one of the most important factors in 10 core industries to support the 5G application services. It is described in the previous presentation from the Skt that 5G MEC is applied by the Korean operators. Skt, TTA, and LG U+, they deployed their own MEC cloud centers in the Korea's big cities, and they provide B2C services such as AR, VR services and cloud gaming, and P2B services. Korean operators install their MEC system to the local specific areas for the purpose of 5G application to the smart factory and intelligent CCTV service with AI and real-time remote control of heavy machine and smart drone and so on. From the perspective of the commercialization, B2C services, the various kind of services based on MEC cloud technology were deployed in commercial stages, and the B2B services described here is on trial phases. And Korean government and operators, they are pushing this kind of use cases advanced to the commercialization phase. One of the commercialization services is 5G cloud gaming. The cloud gaming of low latency and prompt response can be provided by the MEC technology and the advanced technology features of 5G. Cloud gaming is one of the promising commercialization use cases of MEC in Korea. So every Korean operators partnered with Microsoft and so on, and they provide cloud gaming services. So some kind of million size of subscribers will use this kind of cloud gaming services in the future. From the perspective of B2B areas, government lead MEC technology application to the various kind of industry use cases. From 2020, 5G MEC technology application to industries was initiated by the Korean government and subsidiaries. And in 2020, safety and anti-corona, remote learning, road management, healthcare, industry park, and environmental management, this kind of industry application was started from the government-funded project. And last year, 6 industries were selected for the 5G MEC application trial. So harbor, healthcare, military, smart city, smart campus, and smart factory was selected for the MEC and 5G technology application to the industries. And LG U+, KT, and some other organization lead this kind of MEC application trial project. And in this year, this kind of MEC application projects will be continued, and 5G MEC B2B expansion and 28 gigahertz of promotion is under planning for the execution of the project. And some other application of MEC area is 5G MEC combined with the advanced IT technologies such as AI, digital twin, and so on. So the subsidiaries from the Korean government, MSAT, they are promoting this kind of technology merging activities. Another topic for my interest is EUM 5G. EUM 5G is a name of the Korean local 5G policy. Last year, Korean government announced that the EUM 5G policy and allocated a spectrum for local area usage of the spectrum. And this is a little bit lower price of the compared to the operators 5G spectrum auction. And the owner of the factory or other industry site can use their own spectrum for deploying their own 5G technology and their own 5G MEC equipment on their site. To support this kind of policy, Korean government allocate additional spectrum for EUM 5G usage in the site. 28 gigahertz, 600 megahertz, and 4.7 gigahertz of 100 megahertz of spectrum was assigned, and SA 5G technology is assumed for the deployment of this EUM 5G spectrum usage. And so in addition to the operators existing 5G spectrum in 28 gigahertz and 3.5 gigahertz of 5G spectrum, local 5G license of EUM 5G spectrum was additionally allocated. So the 5G and technologies were used for the MEC application to the various kind of industries. This is the current status of EUM 5G business cases. This spectrum allocation was started at the end of the last year, but the first applier for this spectrum usage was Neighbor 1 month ago. They applied the spectrum allocation, and they have a plan to deploy the brainless robot in their site of Neighbor Cloud company. The control of the robot will be reside on their own cloud system, and it will be connected to the robot with the 5G technology, and some kind of MEC technology will be applied for this kind of use cases. In addition to the Neighbor cases, KEPCO, the power company in Korea, and LG CNS, the SI company in Korea, and Sejong Telecom, and some other companies are announcing their own plans of EUM 5G usage and EUM 5G kind of businesses. According to the guideline published by the KCA, the Korean government, the EM5G, the Korean local 5G, will be consisted with two kinds of network architectures. One thing is that allocated standalone system. All of the core network and radio systems will be equipped in their own site. But the other implementation option is distributed implementation. That means core network will be located at the somewhere in the center, such as a neighbor or cloud center, and a radio will be deployed in a local site. In this case, some kind of MEC technology will be applied for the data offloading and low latency and so on. This kind of EM5G, the purpose of this policy is to promote the 5G technology application to the various kind of industries. So some kind of APIs will be utilized for their integration of 5G technology and the industry applications. So MEC usage will be increased with the deployment of the EM5G in Korea. Thank you for your attention.
Yes, thank you very much, Dr. Parker. We're running quite a bit over time, unfortunately. So this leads us, we've had these two presentations of these potential technology blocks, and we wanted to have a very short, and I insist really on very short Q&A session to conclude this, which will be led by my colleague Xavier Piednoir, who manages the Indico project in ETSI. Xavier, can you keep it?
Yes.
Can the participants also keep it very short? Thank you so much.
Yes,
I'll come in when necessary to play the master of the clock. Thank you.
Okay. Maybe first thing is we could check if Emilio has had the opportunity to fix the sound issue, because it would probably be interesting to hear what he was planning to answer to Stefan's question on the the potential alliances of standardization bodies and things like this. Emilio, are you able to?
Can you listen to me now?
Yes, we can.
Okay, thank you.